Hello dear students, welcome back to the online class. Okay, this is the third video for chapter 5, that is periodic table, which is there in your syllabus. Okay, in the first video I discussed about uh, the reasons for classification of elements and the Dauvernier's attempt for classification of elements and his merits and demerits I discussed. Okay, second video I discussed about Newland's Newland's process for the classification of elements, his law, okay, and the table which he gave, the merits on his classification and the demerits on his classification I discussed in second video. Today's video I'll move on to another attempt made for the classification of elements. Okay, and that attempt was done by Dmitry Mendeleev. Dmitry Mendeleev, okay. Mendeleevs, Dmitry Mendeleev. Okay, so first of all, he gave a law for the classification of elements, and his law says that the physical and chemical properties of an element are the periodic function of its atomic mass. Okay, again I will repeat, the physical and chemical properties of an element are the periodic function of their atomic masses. Okay, the word periodic comes from the previous classification which was done by John Newland. Okay, so you note down one question: state Mendeleev's law for the process of classification of elements. And answer you can write, Mendeleev's law says that the physical and chemical properties of an element are the periodic function of its atomic masses. Okay, you can refer your book for the exact law. Okay, now the table which Mendeleev gave was like this. This is 1, this is 2, this is 3, this is 4, 5, 6, 7, and ultimately 8. Okay, one, okay, this side is 1, 2, 3, 4, 5, and 6. Okay, so he made this type of table. Okay, total 8 columns: first column, second column, third column, fourth column, fifth column, sixth column, seventh and eighth column, and rows, total 6 rows. Okay, now column 1 was split into 2 sections, A and B. This also A and B, this also A and B, this is also A and B, this side also A and B. Okay, this also A and B. 7 also he split it in 2 subgroups: group A, group 1 A, and group 1 B. Okay, group 2 A, group 2 B. Similarly, till group 7 he split it into 2 groups. And this rows, first row was usual, second row was also usual, third also usual, fourth he made 2. First series and second series. Here also first series and second series. Here, this also first series and second series. Okay, so the board work may not be clear. Okay, this work may not be clearly visible. Just refer your book for the exact this table. Okay, now first here he kept hydrogen. Okay, and this everything was left blank. Next he kept lithium, beryllium, boron, carbon, oxygen, not like oxygen, nitrogen, oxygen, fluorine. Okay, LiBe, beryllium, B means boron, C is carbon, N means nitrogen, O means oxygen, F means fluorine, and this place he kept blank. Okay, next sodium, magnesium, aluminium, silicon, phosphorus, chlorine. Okay, sorry, not chlorine, sulfur. He kept sulfur here, and here chlorine. Okay, so Na means Latin name of sodium, that is natrium. Okay, Mg stands for magnesium, L stands for aluminum, Si silicon. Okay, P means phosphorus, S is sulfur, Cl, capital C, small l, it is chlorine. Okay, after that, in first series, this is first series. Okay, first series in column A he kept potassium, and here in column A he kept calcium. In column A, okay, he kept Sc. Okay, T he kept here in column B. Okay, in this vanadium he kept in column B of group 5. Chromium in group B, manganese in group B, this iron, cobalt and nickel were kept together in group 8. Okay, copper he kept in second series here, this column B. Okay, zinc he kept in column B, series 2 of fourth period. Okay, he kept here gallium Ga. Okay, germanium Ge he kept here on A, group A, this 4A. Okay, arsenic, this is bromine. Okay, in 7A. So in this way he had arranged some other elements also. Okay, I have done till bromine, Br. So this was the process for arrangement of elements done by Mendeleev, Dmitry Mendeleev. Okay, so hydrogen he kept here. Actually, position of hydrogen was not specified. Hydrogen was not given a proper place. Okay, so this is the process. So question comes: state some essential features in Mendeleev's process for classification of elements. Okay, you can note down this question and answer you write it. The essential features in Mendeleev's process for classification of elements are: number one, he classified the elements by keeping them in groups and column periods. Okay, number two, Total there were 8 groups. Group 1, group 2, group 3, 4, 5, 6, 7 and 8. Groups means vertical columns. Okay. Total there were 8 groups, and group 1 to group 7 were divided into subgroups, which was named as A and B. Group 1A, group 1B. Similarly till 7. Okay, so that is the second essential feature of Mendeleev's process for classification of elements. Third, total there were 6 periods. Periods means horizontal rows. Okay, first period, second period, third, fourth, fifth, and this is sixth. And the fourth period, fifth period, and sixth period were again divided into 2 series, first series and second series. Okay, so this is the third essential feature of Mendeleev's classification. And fourth is very, very important. When we move from left to right along any period, metallic character of element decreases. Okay, so this was the fourth essential feature. So when elements were arranged like this, gradual decrease in metallic character when we move from left to right along any period was observed. Okay, so metallic character decrease. But see, when you move from here, lithium is highly metallic. After that, beryllium less metallic, boron less metallic, this carbon less metallic, nitrogen very less metallic. Okay, so it goes on. So metallic character decreases when we move from left towards right along a period. So this was also observed from the Mendeleev's classification. Okay, so actually this is metal, these are non-metals. Carbon, nitrogen, oxygen, fluorine, they are non-metals. Okay, so metallic character decreases when you move from left to right. So this was observed from Mendeleev's process for classification of elements. Okay, so your question is first question I said you that state Mendeleev's law, or that is also known as old form of periodic law, process of classification of elements. Law says that the physical and chemical properties of an element are the periodic function of its atomic masses. Okay, so that is the law. Number 2, state the essential features of Mendeleev's periodic table or Mendeleev's process for classification of elements. First essential feature is Mendeleev classified the elements by making them by keeping them in groups and periods. Okay, that is first essential feature. Number 2, there were total 8 groups, out of which group 1 to group 7 were divided into subgroups, namely A and B. Okay, third is total there were 6 periods, and period 4, 5 and 6 were divided into 2 series, series 1 and first series and second series. Okay, and fourth is gradual decrease in metallic character when we move from left to right along any period was observed from Mendeleev's periodic table. Okay, so 4 essential features are there. Now next question comes, state the merits, MERITS, merits of Mendeleev's process for classification of elements. The answer will be the merits in Mendeleev's process for classification of elements are: number 1, vacant place or empty place. See, these are empty places. Okay, these are empty places. Gaps, or we can call gaps were kept for undiscovered elements. So that is the first merit of Mendeleev's process, Mendeleev's classification. Okay, so this, in this place later on some elements were kept. Okay, so first you write it, gaps were kept for undiscovered elements. Okay, number 2, okay, next is merit number 2 is, mm, you can say that grouping of elements were done by Mendeleev. Okay, he made total 8 groups and 6 periods for classification of elements. So that is another merit. Okay. Third, the physical and chemical properties of undiscovered elements could be predicted from his table. Okay, see, this place is kept vacant. Okay, so the element which comes later on, its physical and chemical properties can be just predicted. Okay, you cannot say the exact physical and chemical properties, but we can just predict it by seeing the properties of fluorine, and next we have sodium. Okay, its physical and chemical properties will be similar to the element which is present towards left and towards its right. Okay, so that was the next essential feature. Next very very important thing is some atomic masses were corrected. Okay, especially the incorrect atomic mass of gold and platinum was corrected from Mendeleev's periodic table. Okay, so total I said 4 merits. First merit number 1 is gaps were kept for undiscovered elements. Okay, and number 2, he classified the elements by making 8 groups and 6 periods. So that is the essential of this merits. Okay, next number 3, the physical and chemical properties of undiscovered elements could be predicted from Mendeleev's periodic table. Okay, and fourth is incorrect atomic masses of some elements, especially gold and platinum, was corrected from his table. Okay, so this completes the merits of Mendeleev classification. Okay, next comes demerits in Mendeleev's classification for elements. Okay, so write down another question. State the demerits in the process of classification of elements done by this Mendeleev. Answer, you write it. The demerits are: the position of hydrogen was not specified. Okay, hydrogen was not given a proper place in the periodic table. So hydrogen, whether to keep in group 1 or to keep in group 7, that the position was not specified. Okay, the address of hydrogen was not specified. Like for example, suppose if there is a student, say Anil, okay, so he should have a proper address, otherwise we cannot find him. Okay, similarly hydrogen should have a proper address, whether its position is in group 1 period 1 or group 7 period 1. So that was not specified by Mendeleev. Okay, so that is the demerit, first demerit. Next, the position of isotopes were not specified. The isotopes were not given a specific position by Mendeleev. Okay, isotopes means the elements having same atomic number but different mass number, that I have already discussed in previous videos. Okay, so isotopes were not given specific positions. So that was the second demerit in Mendeleev's classification. Okay, third, he kept 3 elements here. Iron, cobalt and nickel were kept together in group 8 period 4. Okay, this iron, cobalt and nickel were kept together within the same group and same period. This one, group 8 period number 4. This should not be done because they differ in some physical and chemical properties. Okay, so that is the next demerit, the position of iron, cobalt and nickel. Okay, iron, cobalt and nickel were given the same position in the periodic table. So that is the next demerit of Mendeleev Mendeleev's classification. Okay, next, copper. See this, copper. Copper was kept in group 1, group 1b. Okay, along with this hydrogen, lithium, hydrogen, forget about hydrogen, lithium, potassium, sodium and potassium. So that is the next defect. Copper, the physical and chemical properties of copper is completely different in comparison to lithium, sodium and potassium. But copper was kept along with these elements. Okay, so that is the defect. See, sodium, lithium, potassium, their valency is 1, but valency of copper is basic valency of copper is 2. So this copper is different from these elements. Okay, lithium, sodium and potassium, but it was kept within a same group. So that is the defect. Actually, copper resembles this iron, cobalt and nickel. Okay, so that is the next defect. So total 4 defects. First is a position of hydrogen. Hydrogen was not given a specific position. That is the first defect. Number 2, isotopes were not given a specific position. Okay. Number 3, this iron, cobalt and nickel. Fe means iron. Latin name of iron is ferrum. Okay, Co stands for cobalt and Ni stands for nickel. So these 3 elements were kept together. Okay, so that is the next defect. Next is copper was kept with this lithium, sodium and potassium in group 1. So that is the next defect. So this completes Mendeleev's process for classification of elements. Now again, people started to do research on proper way for the classification of elements, and later on Henry Moseley came with a new concept for classification of elements. Okay, and he modified the law which was given by Dmitry Mendeleev. So Dmitry Mendeleev had given the law. That law says that physical and chemical properties of an element is the periodic function of their atomic masses. But he said, Henry Moseley said that the physical and chemical properties of an element are the periodic function of their atomic numbers. So instead of atomic mass, he wrote atomic number. Instead of atomic mass, he wrote atomic number. And the statement is same. Okay, the physical and chemical properties of an element are periodic function of their atomic masses. Instead of atomic mass, he wrote atomic number. And this was the most stable form for the classification of elements, and this we follow still till now. Okay, we follow this new law. The physical and chemical properties of an element are the periodic function of its atomic number. This is applicable till now. Okay. So you write down the question. State modern form of periodic law, or state Henry Moseley's law for the process of classification of elements. Okay, and the statement you write it. The physical modern form of periodic law says that, okay, the physical and chemical properties of an element are the periodic function of their atomic numbers. THEIR there. Okay, their atomic numbers. So with this concept, a new periodic table was designed. Okay, and it was done by Niels Bohr. With the concept of this Henry Moseley, Niels Bohr designed a new periodic table, and this periodic table we follow till now. Okay, and the table is like this. One, two, three, 4, 5, 6, 7. Okay, here 1, 2, 3, 4, 5, 6, 7, 9, 10, 12, 13, 14, 15, 16, 17 and 18. Okay, so here total he made 18 groups. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 till 18. Total 18 groups and total 7 periods. Periods means horizontal rows and groups means vertical columns. Okay, so in this position he kept hydrogen. Here in 18 group 1, period 1 group 18 he kept helium. He means helium. Okay, after that here he kept lithium, after that beryllium, after that boron, carbon, nitrogen, Libby. Okay, after that he came to 13. Ne, neon. Okay, Ne is neon. Ne, this is Ne, capital N, small e, neon. Okay, that Kr. Okay, Kr means krypton. So you refer your book for the exact table. Okay. Xe means xenon. Okay, this is 57. Okay, this is atomic number of L stands for lanthanum, cesium, barium and lanthanum. Its atomic number is 57. Okay, so he arranged some more elements are here. Okay, francium is there. Yeah, below cesium there is francium. Okay, so Niels Bohr designed this periodic table. So for exact periodic table you refer your book. Okay, so some words or the letters may not be visible distinctly because of this picture quality. Okay, so hydrogen he kept here first position, group 1 period 1. After that in group 1 period 1 group 18, period 1 group 18 he kept helium. He stands for helium. Okay, after that lithium, beryllium, this place he kept blank from 13, group 13, boron, carbon, nitrogen, oxygen, fluorine and neon. Okay, see here group 3 to group 12 of period 2 and period 3 was kept vacant. This one, this two, you should make this table properly. Okay, and you should memorize also at least till lanthanum. if you memorize till lengthenum, it will be